So we started talking about sound and how sound propagates, and we have a problem that uses some of the formulas we're using for sound and talks about power and intensity again. So this problem says that you've got low frequency speaker of a stereo set. It's got an area of 0.05 meters squared, and it produces 1 watt of acoustical power. Okay? So the question has two things. It says, what is the intensity at the speaker, and at what distance away from the speaker does the intensity go to 0.1 watt per meter squared? So the way that you need to think about this problem is you need to remember that sound waves propagate spherically. We're going to assume that they propagate spherically. This one goes directly out. If you think of a speaker, it's usually got a cone that directs it. But at least in this area right here, these are spherical waves. If you have just a sound source that's not protected at all, it will propagate like this. So when you're thinking about the area that you're talking about, you have to remember a couple of things. First of all, that intensity is power over area, and you have to remember that the area that we're talking about is that spherical wave, which is 4 pi r squared is the area of a sphere. So the first part is what we like to call plug and chug, right? We've got an equation, we know the power, we know the area, so we can get the intensity at the speaker pretty straightforward. Plug it, chug it, you get 20 watts per meter squared. But then you have to remember that you're using an area that's a sphere, and you can rearrange this formula. This kind of looks like a T here, but I promise it's an I. That you get area is equal to power over intensity, okay? And remember, this R is the radius in this sphere. That is the distance we're looking for. So if you rearrange this formula, I actually did it a couple of times for you because there's those square roots that can get a little confusing. You get R is equal to the square root of power over 4 pi times intensity. So then when you plug that, the numbers that you know, remember that it's still 1 watt of power, that's what's producing the power, and your intensity, remember to use your new intensity, which is 0.1 watt per meter squared, and you get that the radius is 0.89 meters, or 890 centimeters, almost a meter. So there you go. There's the solution to the problem. Your intensity is at the speaker is 20 watts per meter squared, and it does not take very long for that intensity to fall off to 0.1 meters. It's less than a meter before that intensity falls off to 0.1 watts per meter squared. That's what we call an inverse square relationship. You see them a lot. And it kind of makes you think a little bit about sound and how things fall off and how sound propagates. So I love that problem. I hope you do too. And I hope it helps you when you're working on the rest of your homework problems.